This is the division with one-digit video. Let's first start with an example, 8 divided by 2. Here you can see 8 divided by 2 equals 4. From the terms defined in the intro video, we can call 8 the dividend, 2 the divisor, and 4 the quotient. Observe that 4 times 2 equals 8 because of the inverse relationship between multiplication and division, like explained in the introduction video. To solve the problem 8 divided by 2, we want to find how many times the divisor can fit into equal groupings of the dividend. Let's think of a number as the number of elements in a group. This means that we are calculating how many groupings of 2 elements can fit into 8 elements. The first example uses a circle split into equal elements of 8. We want to see how many groups of 2 is contained in the elements of 8. We will take away one group of 2 and call this group A. We'll also take another group of 2, call this group B, another, C, and the last group of 2, D. Now we count up the number of groups. So we have 1, 2, 3, 4 groups. Therefore, 8 divided by 2 is equal to 4. In our second example, let's use segments of a ribbon. This ribbon is 8 inches long and has lines every inch. Let's split this into 2 groups. So to do this, we'll divide them equally. And there's 2 groups, 1 group, 2 group. And in each group there are 4 elements, 1, 2, 3, 4, and 1, 2, 3, 4. What happens if the divisor is not a multiple of the dividend? For example, the problem 7 divided by 3. In this case, 3 is not a factor of 7. Please see the factoring video for more information. There are 2 ways that we can deal with this. The first way is with remainders. You use remainders if you want to keep a whole number for the quotient. We subtract 3 in as many groups as possible to divide. So 7 minus 3 is one group of 3. 4 minus 3 is another group of 3. And then there's 1 left over. And 3 cannot fit into 1, so 1 becomes the remainder. So then you have 7 divided by 3 is equivalent to 2 remainder 1. Let's look at this example on the ribbon where 7 elements are represented as 7 inches. Here we will start by decomposing 7 inches into groups of 3 inches. We can show one group of 3 inches and another group of 3 inches. And we have one group left over. This means that 7 can be decomposed into 2 groups of 3 inches with a remainder of 1 inch. The second and third method of solving this problem can be performed under the assumption that the student understands fractions. One can either make an entire number a fraction or have the remainder be a fraction or decimal. Please refer to the fraction notation video for more information. The second method is performed using the distributive property. When decomposing 7, there are 2 groups of 3 and 1 group of 1, which becomes 3 plus 3 plus 1. Then, when we divide this by 3, you have 3 divided by 3 plus 3 divided by 3 plus 1 divided by 3. 3 divided by 3 is equal to 1. Then you have 1 plus 1 plus 1/3 equals 2 and 1/3. The third method transforms the division into a fraction, which simplifies 7 divided by 3 to be 7/3. For more information, please see the simplification of fractions video. We can see that 7 divided by 3 can be written in 3 separate ways. Using the first method, it equals 2 with a remainder of 1. The next 2 methods require the knowledge of fractions. It can also equal 2 with 1/3 and 7/3.